Welcome to Bilal Consultancy Limited, your guide to mastering the art of scatter diagrams. Today, we'll embark on a journey to harness the true potential of scatter diagrams. What is scatter diagram? A scatter diagram, also known as a scatter plot, is a graphical representation used to display the relationship between two variables. It's particularly useful in visualizing how changes in one variable might affect another. Let's dive deeper into the components and the significance of scatter diagrams. Variables and axes representation. A scatter diagram typically consists of two axes. Horizontal, x-axis, represents one variable, often considered the independent variable or predictor. Vertical, y-axis, represents the other variable, considered the dependent variable or the outcome that might change based on the independent variable's value. Data points and representation. Each data point on the scatter plot signifies the intersection of values for the variables being studied. For instance, in a study analyzing the relationship between hours spent studying, x-axis, and exam scores, y-axis, each data point represents a student's score corresponding to the hours they studied. Pattern recognition and analysis. Scatter plots are powerful tools for pattern recognition. Trend identification. They help identify trends or tendencies within the data. For example, an upward trend in a scatter plot might indicate that as one variable increases, the other tends to increase as well. Correlation assessment. Scatter plots can display the strength and direction of correlations between variables. Positive correlation implies that as one variable increases, the other tends to increase too. Negative correlation suggests an inverse relationship. A neutral or scattered distribution might indicate no clear relationship between the variables. Cluster identification. They can also reveal clustering or groupings of data points, which might signify distinct patterns or subsets within the data. No causation but correlation. It's crucial to understand that while scatter diagrams illustrate relationships between variables, they do not establish causation. Even if a strong correlation exists, it doesn't imply that one variable causes changes in the other. It merely shows a connection or association between the variables. Application in data analysis. Scatter diagrams are extensively used in science and research, to visualize experimental data and study relationships between variables. Business and economics, in analyzing market trends, sales data, and forecasting. Quality control, to identify patterns and correlations in manufacturing processes. History of scatter diagram. The history of scatter diagrams or scatter plots can be traced back to the late 18th century, evolving through various advancements in statistics, mathematics, and data visualization techniques. Here's a chronological overview. Early development. 18th century. The origins of scatter diagrams can be linked to the works of Carl Friedrich Gauss and Adrien Marie Legendre, prominent mathematicians who laid the foundation for statistical analysis. They worked on least squares regression, a method used in fitting lines to data points. Evolution in statistics. 19th century. Statistical analysis and graphical representations expanded during this period. Francis Galton, a British polymath, made significant contributions to statistics and pioneered the use of scatter plots. 1886. Galton introduced the concept of correlation through the use of scatter plots. He used scatter diagrams to demonstrate the relationship between the heights of parents and their children, recognizing a trend toward the mean height in subsequent generations. This work laid the groundwork for the concept of correlation coefficients. Formalization and standardization. 20th century. With the advancement of computing and statistical software, scatter plots became a standardized tool in data analysis. 1960s–1970s. The widespread availability of computers and statistical software facilitated the creation and analysis of scatter diagrams, making them an integral part of statistical analysis courses and research methodologies. Modern usage and applications. Late 20th century to present. Scatter diagrams have become indispensable in various fields, including but not limited to data analysis and scientific research, business analytics for market research, sales forecasting, and trend analysis, quality control and process optimization in manufacturing and engineering, understanding relationships in social sciences and public health studies. Technological advancements. Digital era. The digital revolution and the advent of user-friendly data visualization software have made creating scatter plots more accessible to a wider audience. Advanced software allows for dynamic and interactive scatter diagrams, enabling deeper insights into complex data relationships. The evolution of scatter diagrams has been closely tied to the advancement of statistical methods and the growing need for visual representations to understand and analyze relationships between variables. From their inception as hand-drawn plots to today's sophisticated digital representations, scatter diagrams remain an essential tool in data analysis and visualization. Benefits and importance of scatter diagram. Scatter diagrams, or scatter plots, offer several benefits and hold significant importance in data analysis, research, and decision-making across various fields due to their versatile nature and ability to visually represent relationships between variables. Here are some key benefits and importance. 1. Visual representation of relationships. Clear visualization. They provide a clear and intuitive visual representation of the relationship between two variables, making complex data easier to comprehend. 2. Pattern recognition and analysis. Trend identification. Scatter plots help identify trends or tendencies within the data, enabling the detection of relationships such as positive, negative, or neutral correlations. Outlier detection. They make outliers, anomalies, or unusual data points stand out, aiding in identifying data irregularities. 3. Correlation assessment. Correlation strength. They demonstrate the strength and direction of relationships between variables, providing insights into the degree of association between them. Identifying clusters. Scatter plots can show if data points cluster in certain areas, suggesting subgroupings or distinct patterns within the data. 4. Data-driven decision-making. Informed decisions. They assist in making informed decisions based on observed correlations or trends within the data, leading to better strategies and outcomes. Prediction and forecasting. Scatter diagrams help in predicting future trends or outcomes based on established correlations, aiding in forecasting. 5. Research and analysis. Statistical analysis. Integral and statistical analysis, regression analysis, and hypothesis testing to explore relationships between variables in research studies. Quality control, used in monitoring processes and identifying factors impacting quality in manufacturing and engineering. 6. Communication and presentation. Effective communication. They serve as powerful tools for communicating findings and insights to diverse audiences, making complex data more accessible and understandable. Supporting evidence. In academic or professional settings, scatter diagrams provide visual evidence supporting research findings or conclusions. 7. Diagnostic tool. Problem identification. In various fields like healthcare and engineering, scatter plots help identify potential issues or correlations that may require further investigation. 8. Tool for continuous improvement. Process optimization. In industries, they contribute to process improvement by analyzing relationships between process variables and outcomes, aiding in optimization efforts. In essence, scatter diagrams are fundamental in data exploration, hypothesis generation, and decision-making processes. Their ability to reveal relationships between variables helps analysts, researchers, and decision-makers derive insights and formulate strategies based on empirical evidence, contributing significantly to informed decision-making and problem-solving across diverse domains. How to develop it step by step. Creating a scatter diagram involves several steps, from collecting data to visualizing it in a plot. Here's a step-by-step guide. 1. Define variables. Identify variables. Determine the variables you want to study and understand their relationship, e.g., sales and advertising spending, temperature and ice cream sales. 2. Data collection and preparation. Gather data. Collect data pairs for the selected variables. Ensure accuracy and completeness in data collection. Organize data. Arrange the collected data into a table format, with one column for each variable. 3. Data analysis and cleaning. Check for errors. Review data for outliers, missing values, or inaccuracies. Clean the data by removing or correcting any discrepancies. 4. Select axes and scale. Identify independent and dependent variables. Assign one variable to the x-axis, independent, and the other to the y-axis, dependent. Scale the axes. Determine suitable scales to represent the range of values for each variable. 5 plotting data points. Plot data pairs. For each data pair, locate the corresponding x and y values on the plot and mark the point. Repeat for all data pairs. 6 title and labels. Add titles. Title the plot to indicate the variables being analyzed. Axis labels. Label the x and y axes clearly, indicating the variables and units. 7 interpret and analyze. Examine patterns. Look for patterns, trends, or clusters in the plotted points to understand the relationship between the variables. Correlation assessment. Assess the strength and direction of the relationship between the variables based on the scatter plot. 8 regression line, optional. Regression analysis. If needed, perform regression analysis to fit a line or curve that best represents the relationship between the variables. 9 additional analysis, optional. Annotations or trend lines. Add annotations, trend lines, or additional graphical elements to enhance interpretation if required. Subgroup analysis. For complex data, consider subgroup analysis or categorization to analyze specific subsets separately. 10 interpretation and conclusion. Draw conclusions. Based on the observed patterns or correlations, draw conclusions about the relationship between the variables. Document findings. Document your analysis, interpretations, and any actionable insights derived from the scatter diagram. Tips for success in scatter diagram. Here are some essential tips to maximize success when working with scatter diagrams. 1. Understand your variables. Clarity on variables. Clearly define and understand the variables you're analyzing. Know which is the independent variable and which is the dependent one. 2. Quality data collection. Accuracy is key. Ensure accurate and reliable data collection. Even a single error or outlier can significantly impact the interpretation. Sufficient data. Collect enough data points to provide a representative sample for analysis. 3. Data preparation and cleaning. Data integrity. Scrutinize and clean the data. Remove outliers or inconsistencies that might distort the representation. Handle missing data. Address missing values appropriately to avoid skewing results. 4. Appropriate scaling and axis labels. Scale sensibly. Choose appropriate scales for the axes that effectively represent the range of data without distorting the plot. Clear labels. Ensure clear and descriptive axis labels, including units of measurement. 5. Use visualization tools. Select the right tool. Use software or tools suited for creating scatter plots. Excel. Python libraries like Matplotlib or Seaborn, and specialized statistical software can help create accurate and customizable plots. 6. Analyze patterns. Pattern recognition. Thoroughly analyze patterns, trends, clusters, or gaps in the plotted data points to understand the relationship between variables. Regression lines. Consider adding regression lines or curves for better understanding if applicable. 7. Interpret with caution. Avoid assumptions. Do not assume causation based solely on correlation. Highlight that correlation does not imply causation. Contextualize findings. Interpret findings in the context of the subject matter or specific field of study. 8. Communicate effectively. Clarity in communication. Ensure the scatter diagram is clear, well labeled, and easily understandable to your audience. Visual appeal. Make the plot visually appealing without compromising its clarity and accuracy. 9. Continuous learning. Explore advanced analysis. Consider advanced techniques like subgroup analysis or trendline fitting for a deeper understanding of relationships. Keep updated. Stay informed about new tools, methodologies, or best practices in data visualization and analysis. 10. Validate and iterate. Validate findings. Cross-reference scatter plot results with other analytical methods or data visualization techniques for validation. Iterate and improve. Learn from each analysis and improve subsequent scatter diagrams based on feedback or new insights. Applying these tips can enhance the accuracy, clarity, and value of scatter diagrams, empowering you to derive meaningful insights from the relationships between variables. Examples of scatter diagram. Scatter diagrams are used across various fields to visualize relationships between variables. Here are a few examples. 1. Economics and finance. Stock market analysis. A scatter plot showing the relationship between company earnings and stock prices over time can reveal correlations influencing investment decisions. 2. Healthcare and medicine. Clinical trials. In drug development, a scatter plot might display the relationship between dosage and patient response to assess the drug's efficacy. 3. Social sciences. Education studies. A scatter diagram representing the relationship between study hours and exam scores among students helps identify any correlation between effort and performance. 4. Environmental studies. Climate change analysis. Scatter plots depicting temperature changes over time or CO2 levels against sea levels aid in understanding climate patterns. 5. Marketing and business. Marketing spend versus sales. A scatter diagram displaying the correlation between advertising spending and sales revenue helps evaluate marketing effectiveness. 6. Engineering and manufacturing. Quality control. In manufacturing, scatter plots analyzing machine settings against product defects help identify optimal settings for quality improvement. 7. Sports and fitness. Athlete performance. A scatter plot showing training intensity against performance metrics, e.g., speed, endurance, can assist coaches in optimizing training programs. 8. Social sciences and demographics. Income versus life expectancy. A scatter diagram comparing income levels with life expectancy in different regions can reveal socioeconomic patterns. 9. Environmental sciences. Pollution impact. Scatter plots displaying pollutant levels against health indicators in a population help assess the impact of pollution on health. 10. Education and psychology. Learning styles. Scatter diagrams analyzing the relationship between different learning styles and academic achievements provide insights for educators. These examples illustrate the versatility of scatter diagrams in exploring and visualizing relationships between variables across diverse fields. They serve as powerful tools for analysis and decision-making, aiding in deriving insights and making informed choices based on observed correlations. Conclusion. Scatter diagrams are essential tools in data analysis and visualization. They provide a clear and visual representation of relationships between variables, aiding in understanding patterns and making informed decisions based on observed correlations. However, they should be used in conjunction with other analytical tools and methods to draw conclusive insights from data. Stay tuned for our upcoming sessions where we delve into advanced techniques, optimization strategies, and updates to our state-of-the-art tool, ensuring you're at the forefront of scatter diagram innovation.